Hi everyone. So I'm going to call this week 10.4, but it is an extension of last week's material. So this video should go pretty quick. It is literally all about knowing your unit circle stuff, and we're basically just going to be using the unit circle for everything that we do. So there's no new material other than one quick thing. I want to talk to you guys about coterminal angles on the unit circle. So if you recall from a couple note sheets ago, coterminal angles are angles. So this is literally the same definition from the other sheet. I just want to remind you guys. They're angles that have the same terminal side. But you go around more than once. And they can be positive or negative. So today I'm going to show you guys like what happens if you go around the unit circle more than once or if you go in the negative directions. So remember, you can go, so you always start here on the positives and you can go around the x-axis more than once. So like, let's say we wanted to end up here, like this would be once around would be 360 degrees plus another, I don't know, like maybe 120 would be 480 degrees, for example. But that's also coterminal to 120 degrees. So if you just went around once to this side, like, let me switch colors. If you went around once just to 120, that's 120 degrees. But if you start here and go around 360 plus the 120, you end up at 480. So anyways, that's the coterminal and the positive. And we're going to talk about it with radians. And then remember that we can do negative angles as well. So this is 120 degrees-ish, I'm just estimating. Let's call this 120 degrees positive. But negative, that would be, what, 240? Negative 240 degrees if you went here and went backwards. We can also go around, you know, more than once negative too. So like once around the unit circle and then around. So you can go around multiple times in the negatives as well. So this one would be negative, I don't know, what's 360 plus 240? I don't want to do mental math. 360 plus 240. So this would be negative 600. So these are all coterminal. And I'm going to show you guys today how to use your unit circles to create coterminals. So the only missing piece from last week is that now we can have negative radians, or we can have, you know, other values like bigger positive ones. So that's what we're going to talk about this week. So I'm going to do all the pieces again. So I'm going to draw a sketch. So this video might be kind of long just because I'm going to do so many examples, but hopefully they should go pretty quick. So for example, I'm going to teach you guys how to count using a unit circle. Negative 7 pi over 6. I'm going to use my nicer unit circle that I made last year. So something to keep in mind is that the unit circle is just a tool and it's just fractions. And I started to explain this a little bit in the video last week. We start here at 0. We go all the way around to 2 pi. And we're going to stick to radians for the most part. And remember, the pi over 6's reduce. So 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6, 5 pi over 6. And then always, when you get to pi, you guys, it's just, where are my sticky notes? It's like 6 pi over 6. So like once around would be 6 pi over 6, but the 6's cancel, so you just end up with pi. Or same thing for the 3's, right? 1 pi over 3, 2 pi over 3. You get here, and it's 3 pi over 3. And then on to 4 pi over 3. The 3's just cancel out, so it's really, this is 3 pi over 3, 4 pi over 3, 5 pi over 3. And then 6 pi over 3. 6 divided by 3 is 2, so you get 2 pi. So counting around the circle is the easiest way to use the unit circle. It's fraction work, and you have to think about when it reduces. So if you think about it, like this is pi over 4, and this is 3 pi over 4. So in the middle must have been 2 pi over 4. Okay, well, pi over 2. 2 pi over 4 reduces down to 1/2 pi. So it's, pi over 2. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, because it cancels out to be pi, 5 pi over 4, 6 pi over 4 reduces down, 6 pi over 4. If you divide both by 2, you get 3 pi over 2. So 6 pi over 4, 7 pi over 4, and then 8 pi over 4. 8 pi over 4, 8 over 4 is 2 pi. So the unit circle, I just use it to count. And so when you have coterminal angles like that are bigger than any of these, I just like count the fractions. So for the sixths, I use the sixes, the thirds, and the halves because the sixes hit all of those. The pi over 4s use the pi over 4 values and the halves and the pi. Pi over 3s are a little bit nicer because it's like 1 pi, 2 pi. The only you have to watch out is 3 pi, 4, 5, 6. So the only tricky ones to count are I think the sixes are the hardest to count because they reduce the most in the most spots. So I'm going to show you guys how to count today with your unit circle forwards and backwards. But all the values are the same. Everything that you've been doing so far is going to be the same. I'm just showing you guys how to get to different values other than the ones just on the unit circle. All right. So first up, I'm going to talk to you guys about negative coterminals. So going backwards. So negative 7 pi over 6. Okay, so let's think about what positive 7 pi over 6 looks like. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi, oh gosh, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So here's positive 7 pi over 6. How do you get to negative 7 pi over 6? I do the same thing. You just work backwards, right? So here's 0. And find the sixes, thirds, and halves. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and the negatives. So negative 7 pi over 6 is the same thing as 5 pi over 6. So those are coterminal. The negative just means instead of going around to 5 pi over 6, you went negative 7 pi over 6. And so like I said, what I do is I just use the fractions and count. So it's the same thing as 5 pi over 6. So then I'm going to label, what's the reference angle, terminal point, and then sine. I'm just going to use thetas. Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So the reference angle is 1 pi over 6. And that's, so if we were going to, I don't want to draw my thing, but if you're going to make a triangle, your reference angle would be this. And how do you get from 5 pi over 6 to 6 pi over 6? It's 1 pi over 6. And you guys, the reference angle for any of the radians is just like it without, like, what's the reference angle for 3 pi over 4? It's a pi over 4 value, Okay. The terminal point. What's the terminal point that it lives at? Negative root 3 over 2, 1/2. Sine, cosine. So my table isn't as nice. Maybe where's my other one? I'll use my table from my new one. This table is nicer. Pros and cons. My unit circle is messier on the one I did with you guys. My table from last year isn't as nice. So this is where we're just going to use, it's a pi over 6. So it's a pi over 6 reference angle. So that means we're going to use the pi over 6 values. We just have to think about what's positive, what's negative. So in quadrant 2, so this lives in quadrant, I forgot to label quadrant. There we go. It's 5 pi over 6 lives in quadrant 2. So we're in quadrant 2. So that means your point is here. So it's going to be x is negative, y is positive. So sine's positive, cosine's negative. Great. So sine of pi over 6 is 1/2. Cosine is root 3 over, you guys can't see, is root 3 over 2, but it's going to be negative because it's in quadrant 2. So sine over cosine, so tangent's going to be negative. So it's going to be negative root 3 over 3. Cosecant, well, if sine's positive, cosecant will be positive. So 2 secant will be negative because cosine is negative. Negative 2 root 3 over 3. And then cotangent will be negative because tangent is negative. All right, so nothing has changed. I don't think I'm actually going to do all of this work for every example because I think I'm going to be here for a while if I do. I just want to show you guys how to count and get to the right spot. All right, so next up is negative 2 pi over 3. So 2 pi over 3 lives here. So we've gone 1 pi over 3, 2 pi over 3. But we want to go negative, so that means we have to start here and go negative. So negative 1 pi over 3, negative 2 pi over 3. So negative 2 pi over 3 is really 4 pi over 3, positive. So negative 2 pi over 3 is the same thing as positive 4 pi over 3. So those are coterminal. So really all I do, you guys, is I just figure out what is this one equal to. And I just do all the work for the one that you know. All right, so 4 pi over 3 is in quadrant 3. So it lives here. So that means both things are negative for your terminal point. It's in quadrant 3. Your reference angle. Well, if it's a pi over 3, then it's a pi over 3. Your distance is a pi over 3. Your reference angle is a pi over 3. Your terminal point, well, your terminal point is negative 1/2, negative root 3 over 2. And then I'm going to do sine, cosine, tangent for this one again. Cosecant theta, secant theta, and cotangent theta. All right, so I'm going to go back to my chart. This is the pi over 3 values now. So I'm going to use the pi over 3 values, and we have to think about it's in the third quadrant. So that means both things are negative. So sine and cosine will be negative, and then a negative over a negative makes a positive tangent. So sine and cosine are just your pi over 3 values, but they're both negative. So negative root 3 over 2. Cosine is 1/2, so it's negative 1/2. And so that means tangent's positive because it's sine over cosine, negative over negative makes a positive. So tangent would be root 3. So cosecant's negative because sine was negative. So cosecant is 2 root 3 over 3. Negative. Secant will also be negative, so negative 2. And then cotangent will be positive because tangent's positive, root 3 over 3. All right, so really all we're doing, you guys, is we did the legwork to figure out all the trig last week, right? There's no need to keep doing all the trig functions. That's why we make a table. We use our table. This is now really just a tool where you guys are copying down values. The theory is hopefully over time with working with them, you start to kind of memorize them. And so then when you get to pre-calc, when you need to know them kind of off the top of your head more often, or calculus, the more that you work with these, the better you remember them and understand the relationship. So for the next two, I'm just going to talk about how to find where it lives. I'm not going to do all the trig stuff. If you want me to do the trig stuff, just send me an email and we can Zoom and we can do it together or something. All right. Negative 3 pi over 2. Okay. Well, let's just think about where positive 3 pi over 2 is. So here's pi over 2, pi, here's 3 pi over 2. And so the pi over 2s are just counting halves. So, but instead of going positive to starting here and going around in the positive direction, we're going to start here, go around negative. So negative 1 pi over 2, 2 pi over 2, 3 pi over 2. So negative 3 pi over 2 is really just pi over 2. Those are coterminal. So I'm going to do all the work for pi over 2. So pi over 2, it doesn't live in a quadrant, right? Quadrant. None, it lives on the y-axis. So it lives here. You know, here's your terminal side. We went negative 3 pi over 2, but you could also go pi over 2. They're the same thing. And the terminal point remains the same. It's 0, 1. And all the values for this are on your chart. So if you need the trig values for pi over 2, they're all here. Yeah. The reference angle is pi over 2. All right, I'm not going to do the trig for all of them. They're literally on your chart. Hopefully you guys are starting to get used to using your chart as a tool, or at least using mine if you don't have a printer or something. Negative 7 pi over 4. Well, let's figure out where 7 pi over 4 is. Here's 7 pi over 4, so that means we've gone around 1, 2, 3, 4, 5, 6, 7. So now we're going to go backwards, though, because we want negative. So negative 1, 2, 3, 4, 5, 6, 7. So negative 7 pi over 4 is the same thing as pi over 4. They are coterminal. So if you sketch this one, if you go around negative 7 pi over 4, oh, geez, I should have started here. My bad. Wait, where's my line? Bad. If you start here and go around, if you start at 0 and go around, that's negative 7 pi over 4. If you start here and go up, that's what I was trying to talk about, is pi over 4. So they're coterminal. They mean the same thing. You end up in the same spot. You've gone, this one's just gone farther in the negative direction to get to the same spot. So this would be in quadrant 1. The terminal point is root 2 over 2. Root 2 over 2, both positive because it's quadrant 1. The reference angle is, you can see it already, is pi over 4. And then so you would use your pi over 4 values from your chart to do all the trig. Okay, so hopefully negatives are going okay. Literally, it's just all about using your unit circle and counting. So hopefully you're okay with counting. I talked about it a little bit last week. You're literally just using the fractions. 1 pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6. 5 pi over 6. 6 pi over 6. And if you ever get off count, it should help you, it should help you end up getting on the right track. Because 1, 2, 3, 4. If you end up here and you're not saying 5, then you missed one somewhere. 6, 7. So the unit circle should help you balance back out. Like 1 pi over 4. If you go 1 to 2, like you realize that something's wrong. If you say 1 pi over 4, 2 pi over 4. No, why? That says 3. I missed something. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. What you're saying should match. That'll help you make sure you haven't missed anything. And then the pi over 3s are the easiest. 1 pi over 3, 2 pi over 3, 3 pi over 3, 5 pi over 3, 6 pi over 3. All right, so next up, I'm going to talk about how do you find any coterminal radian measures. So 19 pi over 6, it's positive. So that means we're going to start here and go all the way around. But is there a 19 pi over 6? No, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So once around the circle is 12 pi over 6. But they want 19. So that means you've gone 12 and then some. So this is a coterminal angle where you're adding. So you've gone around once and then you're adding more. And so 19 pi over 6, well, that's what it was, right? Yeah. So let's count. So once around the circle is 12, 13, 14, 15, 16, 17, 18, 19. So 19 is the same thing as 7 pi over 6. So the trick to this stuff, you guys, is just counting using your unit circle. So that's really the only thing I'm adding this week, because then you guys can go through and fill in the values for 7 pi over 6. You guys know how to do that. All we have to do is just find out what is this crazy one the same thing as. So 7 pi over 6 lives in quadrant 3. 7 pi over 6 is right here. So both pieces are negative. Quadrant is 3. The terminal point is negative root 3 over 2, negative 1/2. And the reference angle is pi over 6. And then to do the sine, cosine, I'm not going to do them for all these because I don't want to waste your guys' time. Is, you find your pi over 6 values using your chart. Pi over 6, make them both negative. Make cosecant, secant negative. Tangent and cotangent would be positive. All right. Negative 11 pi over 3. Okay, well, first of all, it's negative, so that means we're going backwards. And then second, is there an 11 pi over 3 on here? No. 1, 2, 3, 4, 5, 6. So once around the circle is 6. So we're going to be counting around, but hold up, it's also negative. So we're going to be counting around multiple times in the negative direction. So once around in the negatives is negative 6. So I'm going to show you guys, negative 1, no, sorry, thirds. Negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, negative 6 pi over 3. So once around is negative 6, and we need negative 11. So negative 6, -7, -8, -9, -10, -11. All right, so it's the same thing as pi over 3, which is in quadrant 1. Terminal point is 1/2 √3/2. Quadrant 1 reference angle is pi over 3. And then you would just literally use the pi over 3 chart, fill in the trig functions. 15 pi over 4. So again, is there a 15 pi over 4 anywhere in here? No, the highest it goes is 7 and then 8. So once around is 8 pi over 4, so we need to find out where 15's at. So it's positive, so we start here and go all the way around to 8, okay? 9, 10, 11, 12, 13, 14, 15. So 15 pi over 4 would be the same thing as 7 pi over 4. So let's just double check that one, because remember you have to use the halves, right? Because they reduce down. So 8, 9, 10, 11, 12, 13, 14, 15. All right. So then really it's just 7 pi over 4, which is in quadrant 4. Your terminal point is √2/2, -√2/2. Quadrant 4, your reference angle is pi over 4. And then you would just use the pi over 4 values from your chart, fill in the trig functions. All right, up next is -7 pi. This one's awesome. Okay, well, let's think about it like this. You know, here to here is a pi, and then back is 2 pi. So really, you're just like doing a half circle 7 times. And instead of going in the positive direction, we're going in the negative direction. So -1 pi, -2 pi, -3 pi, -4 pi, -5 pi, -6 pi, -7 pi. So -7 pi is the same thing as pi. Pi is the easiest to count because, you know, it's just, you start here and it's 1, 2, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. But this one's negative though, so -1, -2, -3, -4, -5, -6, -7. So -7 pi is the same thing as pi. So again, pi doesn't live on a quadrant. It lives on the x-axis out here. And the terminal point is -1, 0. The reference angle is 0 because it's, you know, there is none. So then you would just do the trig functions for pi. Last one's 9 pi over 2. Okay, well, gotta count quarters. Because, let's see, we've got 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. We need 9. So we're at, once around the circle is 4 pi over 2. 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. So 9 pi over 2 is the same thing as pi over 2. Which again, for a quadrant, none. You know, it lives up here on the y-axis. Your terminal point, 0, 1. Your reference angle is pi over 2. All right. And then, once again, you could just, you know, use your chart for pi over 2 trig values. And then our last one we'll talk about is 14 pi over 3. So again, this is one, once around the circle is 6 pi over 3. So we're going to be counting for a while. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. And it's positive, so we're going to be going positive. I'm going to end up at 14. All right. 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3. All right. We need 14, so we're at 12. 12 pi over 3. 13 pi over 3, 14 pi over 3. So 14 pi over 3 puts us back at 2 pi over 3. So this is the same thing as 2 pi over 3. And so then you just go through and fill in all your trig values from 2 pi over 3 because they're the same thing. So 2 pi over 3 is in quadrant 2. The terminal point is -1/2 √3 over 2. And the reference angle is pi over 3. And then you can go through and use your chart for all your trig functions. All right, guys, so I didn't add much this week, just talking about, coterminal angles, how to go around your circle by counting the fractions in the positive directions, the negative directions. So your homework this week is going to be very similar to last week's, and I actually think it's some of the same exact questions, except now all of your radians that you're dealing with are coterminal, so they're going to be more times around the circle, positive or negative. All right, let me know if you guys have any questions. Thanks.